Well, hello and welcome to everybody who's been able to join. We are going to get started here in a moment. If Mike could please pull up the first slide. Just a couple housekeeping issues. If everyone could please keep themselves muted while the presentations are being given. We will have some time for a little bit of discussion at the end. If you have questions, could you please put them in the chat? We'll be saving all the questions to the end of the presentation. I'd like to introduce our panelists today. Mike Holsinger is an outreach account manager at TRC Companies. He is part of the team implementing energy efficiency programs for New Jersey's Clean Energy Program, with lead responsibilities for the Combined Heat and Power Program, the Large Energy Users Program, the Higher Education Decarbonization Pilot, and outreach to national accounts. He is a certified energy manager. Gearoid Foley has worked for the past 3 decades on construction, HVAC, and on-site power industries. He has collaborated with the Department of Energy, various public utilities, and state energy agencies, developed projects, energy service companies, and major equipment manufacturers, amongst others. Mr. Foley founded Integrated CHP Systems Corporation in 2003, which provides consulting services to the on-site energy industry. He is a founding member of the USCHPA Programs Committee Chair of ASHRAE's Combined Heat and Power Systems Technical Committee, and the New Jersey Director and Senior Technical Advisor for DOE's CHP Technical Assistance Partnership. He co-authored the 2015 ASHRAE CHP Design Guide as well, and has recently published a book entitled Sustainable On-Site CHP Systems. Valentina Rozanova is the Director of Engineering at TRC Companies. Val has 15 years experience in commercial, industrial, and multifamily energy efficiency incentives program management. During this time, she has designed, launched, managed, and supported a variety of energy efficiency programs, including the New Jersey's Clean Energy Program, Paper for Performance, and Combined Heat and Power. Val is a professional engineer in the state of New Jersey, holds a bachelor's degree in civil engineering from Syracuse University, and a master's degree in energy management from New York Institute of Technology. Thank you.
Well, thank you, Tara. My name is Mike Holsinger, and I am, when you hear those introductions, and I actually feel like part of this audience. This audience is very diverse. We have folks from educational institutions as well as from industry, some of whom are more familiar with combined heat and power than others. And I want you to know that on that spectrum, I too studied engineering at the University of Notre Dame for 8 whole weeks of my freshman year, until I decided that that was above my pay grade. So in that spirit, we want to kick off the presentation today with just a very brief grounding definition here for you. We're talking about combined heat and power, and this slide doesn't want to show up. Here we go. So combined heat and power is the production of electricity and useful thermal energy from a single fuel source. And fuel cells, which are also part of the incentive program, produce electricity through an electrochemical reaction from a fuel source. Now, essentially what this means is that the fuel that's used to drive a turbine or a generator, there are different types of generators, but basically the fuel is starting here, and traditionally, once that turbine is up and spinning, the heat that's used to create that activity goes up through a smokestack, never to be seen again. And with combined heat and power, that heat is harnessed. Instead of just simply being waste, it's used to make hot water or steam and handle the building's thermal loads as well as energy loads. And so with that, at least that little bit of grounding, I'd like to turn this over to Gearoid, who studied for more than 8 weeks, and he'll take you through some of the trends and what's happening in the CHP world.
Thank you, Mike. And yeah, studied is all relative, but yeah, I did spend more than 8 weeks in engineering for sure. So next slide, please. And I'll go through here in a short space of time, just kind of touch on a number of issues. So kind of leveraging from what Mike just said in terms of the recovery of the heat from the power generation process. That is the essential definition and benefit of combined heat and power. So it's more efficient than doing separate generation of electricity and heat, as is typical for many buildings. Importantly, and I'll touch on this at the end of this session, CHP can operate on a variety of fuels, and that covers biomass, biogas, natural gas, hydrogen syngas, and maybe importantly, as we move towards decarbonization, a blend of these is fully acceptable to combined heat and power technologies. The higher efficiency simply means you use less of the source fuel, so that generally and certainly in New Jersey does lead to lower operating costs, but be aware, obviously, there is a capital investment required. Higher efficiency also is the linchpin for the reduction in emissions that we see from CHP. And again, I'll talk to that a little bit more towards the end. And then importantly, from kind of a resilience and grid stability perspective, CHP being an on-site energy generator increases reliability and power quality at site. And by essentially generating power at site, we're of course removing part of the grid congestion, as well as the need for added distribution systems to get power from way out on the gridosphere to your building. Next slide, please. So, and I guess I didn't realize this was animated. Give it one more click, Mike, please, to get that second graphic up. Thank you. So this is kind of a graphic, and this is EPA, so the U.S. Environmental Protection Agency, and very similar numbers and thoughts from the Department of Energy as well, but these are EPA graphics. And this essentially shows just exactly what Mike kind of explained. Here on the left-hand side of the left graphic, we have separated power plant and a on-site boiler using gas from the grid at calculated 50% delivery efficiency versus combined heat and power, which essentially does both functions with the same fuel source and therefore resulting in a 75% efficiency. These would be higher heating value efficiencies, but you can see that there is a 50% increase in efficiency. And the graphic on the right-hand side, which is a generic US, fairly current, but reflects the US grid, that results in a 51% reduction in CO2 emissions in this case. The percentage of grid emission reductions derived from applying CHP does vary by region. It does depend on how clean your grid is. Generally in New Jersey, we would expect about a 30% reduction, from today's grid using separate heat and power systems versus a combined heat and power plant using natural gas. Next one, please, Mike. So I'm going to just spend a couple of minutes talking about the marketplace for combined heat and power, and recognizing that this is the Campus Consortium for Decarbonization, so relative to campus type scenarios. First of all, and this is a generic list again from the Department of Energy. So you can see in the industrial, I've kind of highlighted in red a number that I believe are relevant to New Jersey and particularly to campus applications. So food processing, I'm just on the industrial sector, is highly amenable, and the common trend here that you're going to see in all combined heat and power applications is the availability of a thermal load that can be addressed by the CHP plant. So typically these CHP systems are capable of producing steam, medium high pressure steam, or hot water, and that can then be easily converted into chilled water. So you can get a variety of outputs from a combined heat and power plant, primarily power, but also steam, or hot water, and or chilled water, and dehumidification would be another option here for a thermal output. So that's why kind of food processing is highlighted here. You know, bottling, canning industry as an example, very significant use, continuous use of hot water and steam in the process. Pharmaceuticals, both process steam on one side and also process cooling. So from an industrial perspective relative to New Jersey, there are two homes for CHP that we see do avail themselves of CHP very regularly. Looking at the commercial list, data centers, not to highlight them as a specific application, but really in recognition that most college campuses now do incorporate some form of a data center on site. Hotels, from the same perspective, hotels and casinos, not suggesting we should be putting casinos in our campuses, but certainly hotels, yes, and multifamily housing is an essential part of a university today. So they are all very amenable because of that thermal, that availability of a consistent 24/7 thermal load in the case of data centers. Multifamily housing is a good example and very well utilizes CHP very frequently, where we do heating in the wintertime and then cooling in the summertime with the combined heat and power plants. On the institutional side, hospitals are absolutely a go-to. I'm going to talk about that through some examples in a minute. Obviously, universities and colleges are kind of focus here on campus life. Wastewater treatment facilities and correctional facilities I've kind of put up here, and I'll reference one new wastewater treatment facility. And again, not suggesting that we need to locate correctional facilities at campuses, but be aware that they are excellent locations for combined heat and power, and particularly wastewater treatment plants. So there is opportunities here as we kind of move forward with microgrids to potentially combine some of those attributes. And the attribute that I'm always looking for with combined heat and power is that consistent thermal load. So if I have a wastewater treatment plant close by, they can use heating for digestion, typical application, then maybe I can, it helps to kind of co-fund, co-locate, and very compatible with some of the loads that we see in universities, which can be quite variable depending on what season we're in. And just to highlight one on agricultural, CEA, controlled environmental agriculture, is, and certainly with Rutgers have a significant agricultural program, but it's also another opportunity. So we look at some of the vertical farms that have been developed over the last couple of years. Certainly could be located at or close or adjacent to a campus, as well as greenhouses, etc. And one of the attributes of CEA is you can sort of turn the load off arbitrarily, in which case it provides the opportunity to basically swing that energy generation from the CHP plant that normally may serve a controlled environmental agriculture installation in the event of an emergency, a shortage of power on the grid. You can simply turn the lights off for 4 or 6 hours at a greenhouse or a vertical farm, without really any detriment to their business model, and use that to sort of support the campus, et cetera. So I think co-location, we're starting to see as more and more of a theme, and combined heat and power is an integral part of that effort. So next slide, Mike, please. And I'm going to move through a couple of examples. And, this is kind of part of the rationale here is I want to show a variety of examples and how CHP can be applied, but also, to assure everybody that the rumors of the death of CHP are highly exaggerated. In this case, we're looking at this is these guys, Gloucester County Municipal Utility, just closed on their loan from the iBank, which is an infrastructure bank in New Jersey, to allow them to move forward this project. This project is also backed by the Board of Public Utilities and TRC, involved in helping to move this project forward. Here, instead of historically they had incinerators that essentially burn the sludge to reduce the volume, et cetera, and help to deal with the problem of sludge disposal. That's no longer acceptable to the EPA. So the alternative methods looked at incorporated numbers of options, but the one that was selected here was to add digesters, which is quite a heavy lift cost-wise, and then use those digesters to generate biofuel, which is then used to run two 600 kW reciprocating engines. And so this is a renewable combined heat and power plant, and an elegant solution, with a view on the long term. There's a long term, certainly the analysis was kind of looking at the operation and maintenance costs over the long term, together with the alternative, which was dealing with, large volumes of sludge that would need to have been moved off site. So here, CHP will generate steam that can be used to help dewater that sludge, as well as provide power for the facility. So this is a project, as I said, that just closed on the loan. So this is a groundbreaking new project that we anticipate will start groundbreaking this year. Next slide, please. This is the one I've been involved with myself. So this is the flagship hospital for RWJ Barnabas Health in Livingston, a very significant hospital. I think they're up to close to 1 million square feet of space at this point, 3/4 or 1 million square feet, serving 3 million patients per year, 37,000 employees. So a very significant medical center with a variety of treatments. I know it's one of the major burn centers in the state, and a kind of a location for emergencies for New York City in case of natural disaster or other. So quite an important installation. They've installed a 2.5 megawatt CHP plant that was started up at the end of 2022, has been running since. Saves $1 million a year in energy cost, with a maintenance cost runs about $250,000, significant portion of it, but essentially the net savings around $750,000 a year at current energy costs. Adds resilience to the site, and that was really the motivation for the program here, which was supported by the New Jersey Economic Development Authority. So this is post-sanding money used to shore up our infrastructure and provide resilience to our medical centers. And here, this was designed to work in conjunction with the existing diesels and on-site diesel storage that would allow the hospital to be able to maintain services at or close to normal in a long-term grid outage. So quite a significant move. Prior to the addition of this facility, the hospital met its obligations for resilience, which is to back up emergency and life safety, et cetera. That does not include air conditioning. And of course, if power went out in the summertime, if you had no air conditioning in this hospital, then you are not going to be able to maintain the facility and you would have to move patients out of the hospital. So the addition of this 2.5 megawatt CHP plant really bolsters the resilience in the real world here. And just a side note on the picture on the bottom right, this was built atop the existing boiler plant, adjacent to and on top of the existing boiler plant to comply with local labor requirements that the steam generation portion of this be within sight and sound of the boiler plant. So, quite a bit of effort here and quite a unique solution, but something, if you're passing by, it's worth a look. It's quite an impressive installation. It sits atop without touching the boiler plant, sits on top of the boiler plant. This unit also provides steam 12 months of the year, as well as hot water. It's a reciprocating engine-based system, so it'll provide hot water from the jacket in the winter that's tied into heating loads. And in the summertime, that's directed to an absorber that provides cooling to the central plant, and that's distributed throughout the hospital. In addition to this, so this is the first one completed at Barnabas. There's 3 others coming at Barnabas Hospital. So there is Somerset is about halfway through. That's anticipated to start this year. Should be started up in the summer. Jersey City Medical Center, also a 1.5 megawatt similar type system that will be started up in 2024, and a 2 megawatt CHP plant, again, providing cooling, heating, and steam to the campus that is a little delayed, but is anticipated to start end of 2024 or Q1 of 2025. So quite a lot of activity in the CHP space that's ongoing as we speak. Next one, please, Mike. This one here, I just wanted to throw this one up. It's kind of an alternative. This is a Merck pharmaceutical facility, the main campus in Rawway. And they added a couple of 75 kW packaged CHP plants. And I wanted to highlight this one for kind of the ease of installation. So the picture on the bottom is the CHP plant. It incorporates hot water recovery, so that this is kind of really designed to be plug and play, and at this size level, that's very amenable. And again, this is another project. This is a new project started in 2021, and again, supported by TRC, by the Board of Public Utilities through the CHP program. Next one, please, Mike. So here, this is the one in Connecticut. I just wanted to kind of throw this one up. It's a well-cited one in DOE's world, but I'm kind of putting this up because I think it's relevant to us here in New Jersey as we kind of move towards energy transition. This was in southeast Connecticut. There was significant concerns and problems relating to congestion, just a lack of transmission, essentially getting power into southeastern Connecticut, which is the main load pocket. And so they incentivized companies to implement CHP, which basically took that load off of the system so that load is available for other entities in the community. That saved them having to build a new transmission line. So this project, which is a food processing plant, is one of the ones that availed of that incentive back in 2009. This was installed and started operation. And you can see from the testimonial here that, it was seen, it's not only is it providing energy and cost savings to the site, but it is in alignment with their sustainability plan by reducing emissions, and it provided the major benefit for the incentive was to avoid the cost to the ratepayer of bolstering the transmission system in Southeast. So it's quite a success story here. So we'll move on, Mike, to the next one, please. And I'm going to sort of change horses, and I should have ran through the thing. I dislike, I won't use the word hate, these animated slides. So can you just click once and keep going, Mike? I think there's maybe 4 of these. That should be good. Thank you. So this is again, and this is looking from EPA, federal EPA's perspective, looking at combined heat and power. Federal EPA is a very strong supporter of combined heat and power, as is the Department of Energy. Here, so in the chart on the right-hand side, the map of the United States is indicating areas where essentially marginal grid emissions are high. So marginal grid emissions are those that are used on the margin. That means that it's the plants, the non-baseload plants. So when you look at the grid mix out there, nuclear power is a baseload only option, cannot be turned up or down. So it's plugged into the baseload and you start it and it stays running 60 years, 80 years effectively, with minimal interruption for repowering. Hydro can be on the margin or can be base load. Coal is typically base load. There's still a lot of coal out in the Midwest, very large plants. They're also hard to kind of turn up or down, so they typically are in the base load category. What's on the margin are those plants that have a lot of flexibility to be able to ramp up or down as needed. And that is typically natural gas, predominantly some coal. Hydro, when it's available, is dispatchable, and also some oil. So what this is looking at is really the emission signature from the non-base load or the marginal assets on the grid. And this is in accordance with EPA methodology. When you deploy, as we did, for example, the 2.5 megawatts that's deployed in Livingston at the hospital, we're not going to turn a nuke plant down by 2.5 megawatts. What that allows you to do is to reduce the call on marginal plants, those variable plants, and therefore the offset is related to the emissions from the marginal plants. So this map shows you effectively the marginal emission signature, and you can see it varies from about 1,000 pounds per megawatt hour all the way up through, close to 2,000 pounds per megawatt hour, where you have a heavy predominance of coal, which is both base load and marginal, of course, in those areas. Even when we're all natural gas and CHP is natural gas, you still get the benefit of the higher efficiency of CHP, typically even against a very efficient grid plant, but also the grid losses, transmission distribution losses are not associated with CHP. That gives CHP an advantage, even if it's kind of a one-to-one on emission signature for power generation. So what we're looking at is the options here, and the regions in green, provide lower emission reduction potential for CHP in all cases. CHP is about, pick a number, but about 700 pounds per megawatt hour would be a kind of a midpoint. It certainly goes lower, about 500 in the best cases, a little bit higher in the worst cases, but a well-designed, highly, with a high load factor and good thermal loads, it's going to run about 650, 700 pounds per megawatt hour by contrast. So emission savings are seen all around. This is 2021. That would not have changed significantly today. That, of course, will change as we move forward in the transition. But as of today, we can certainly reduce emissions through the application of CHP. And you can see in I always like that quote in the bottom, because emissions are cumulative, and because we have a limited amount of time to reduce them, carbon reductions now have more value than carbon reductions in the future. The next couple of decades are critical. So what we're saying there is that, let's grab what we can immediately, and that will pay big dividends because it is cumulative, and as the grid transitions, we can adjust to that. But right now, we can certainly improve on existing emissions from power generation. Next one, please, Mike. And this one is essentially, and sorry, go through the same process, please, should be 4 clicks, get us there. So this is the same sort of points that I made earlier on. This is a chart, and I believe these slides will be made available, so you can have this later on. This is from the Department of Energy. And what it shows is effectively combined heat and power in today's grid has more of an emission reduction impact than either solar or wind. And that's based on the fact that, looking at PV as an example, while it has 0 emissions, it has a 20% load factor, and CHP that reduces emissions by 30% has a 100% load factor. So while the sun is shining, PV is better than CHP, but for the remainder of the time, CHP will continue to remove and reduce emissions. And so the net impact versus today's grid is actually CHP will remove more emissions than PV or wind. So I think we'll move on to the next one, Mike. I expect that a number of these slides may cause some controversy or issues, and I'm sure Tara will be happy at any time to kind of discuss in further depth any of these issues as you guys want. So here, and I'm got one more slide, so I'm kind of wrapping up this piece of it here. This is looking at New York. We're involved in helping, in New York, we do get involved in policy work there and just supporting CHP, yes, but trying to support the transition in New York. As many of you may be aware, the New York ISO has been sort of ringing the alarm bells for a little while now. So they've been unwinding natural gas for generation, which has always been that kind of go-to when you need that additional power. And with the intention of replacing it with renewables, but the intermittency of renewables is somewhat of an issue. So when we're looking at from an ISO perspective, who are charged with managing the grid and maintaining reliability, that is their mandate, they're getting very concerned. Those reliability margins that are enforced through the federal agencies, they're basically not being met in New York anymore. And it's a little bit of a dangerous situation as we await the development of renewables to replace the natural gas that's kind of not being built anymore. There is a little bit of an issue here in between in that transition, that could impact reliability, and this is particularly for downstate New York City. Another, one of the issues here is, of course, CHP is fuel flexible, as I kind of mentioned at the outset, and so it can transition to renewable fuels, hydrogen. Most of the technologies that are employed with CHP today are actually capable of using hydrogen, using a mix of them. Renewable natural gas is nothing new. Biofuels are very traditional fuel for combined heat and power. So combined heat and power being the most efficient use of those fuels, which will be, expensive and scarce, would be the right way to apply or to use those fuels, use them in combined heat and power, identify where the thermal loads are, and use that to help offset the need for additional resources on the grid. And, to that point, the higher efficiency, lower use of these fuels will, of course, extend those resources better than any other technology approach. And then next one, Mike, please, is the last slide on this. And I just wanted to kind of wave the flag here again for the feds. So the IRA introduced a sort of groundbreaking set of rules here. First of all, increasing the tax credit for combined heat and power to 30%, and you can increase that by another 10% if you use US materials. Generally, there's some rules around that we can get into at another time. This is also available to nonprofit entities for the first time. That's kind of what's groundbreaking about this. Not only is it a 30% and a significant increase in the traditional 10% tax credit, but you as a nonprofit entity, including universities and hospitals, can actually get a check in lieu of the tax credit. So it's a very important change. Now, there is a deadline on this. It was introduced and they're still putting the rules together. But by January 1, 2025, it changes to only support fully renewably fueled CHP. There is moves to certainly try and extend this I expect that could be successful, that we would get a longer runway to allow you to avail of these tax credits. And the basic deadline is you need to spend about 5% of the project value by December 31st, 2024, in order to get in under the window. You then would have several years to complete the project, but just as an added incentive. And I think that's a good hand back to you, Mike, and encouragement to really look at this year together with Mike's program that he's going to get into, of helping to kind of understand and assess that with a lot of support from TRC. It's a great time to look at CHP. So with that, I'll hand back to you, Mike.
Thank you very much. Wow, I got a quick trigger finger. So I hope that by now, during this half hour, 40 minutes or so, that we have sparked some imagination and some creativity around thinking, wow, CHP could be a really interesting option. But boy, can I afford it? And that last slide certainly offers some really interesting encouragement in that arena. And I'd like to spend the next 4 or 5 slides talking about some new enhancements to the New Jersey's clean energy programs, the combined heat and power program. So next up, just an overview of the program. This is the commercial heat and power program is for existing or new construction, commercial, industrial, and large multifamily properties with a commercial account. If it's condominium kind of situation with 300 different accounts, that wouldn't be eligible. This is obviously best suited for facilities with year-round power and thermal loads. So universities certainly fit into that description. This is not measured based on size to qualify as much as it is time, right? So projects have to run 5,000 full load equivalent hours per year, 3,500 for critical facilities. And then, really this is the last sort of summary of why we're so excited about this program. It does reduce demand on the power grid. It does lower energy bills, and it's a significant contribution to reducing greenhouse gas emissions. The other really nice part about this is that they can be designed with black start capabilities so that they can power up when the grid, should the grid go down entirely. It is a really worth investigating. Now, this is admittedly a very difficult slide to grasp, and it's important that you just simply know that it's also on njcleanenergy.com if you'd like to study it a little bit more. It's here to show that there are really a great deal of options to find great incentives for combined heat and power systems of every size. Fuel cell technology is also supported, and the program offers flexible options there too. Now, the program has very generous incentives that help to make CHP even more attractive. Now, here's an example. Let's say a high-rise apartment building might be considering a combined heat and power system. And maybe they've decided that they need a 500 kilowatt system. 500 kilowatts, 500,000 watts. We look at the chart, the incentive is $2 a watt, and that means that they could be eligible for $1 million. Now, maybe a regional high school would be a very different sort of circumstance. They might only need a 50 kW system. Using the same math, they could be eligible for $100,000. And here's a really cool feature about this. When the system exceeds one incentive tier, the incentive per watt goes down, but the total incentive doesn't. And here's how it works. So let's say, well, let's go back to that high rise. And let's say that instead of 500, it needed a 600 kilowatt system. So the first 500 is still eligible for $2 a watt at $1 million. And the next 100 kW is incentivized at $1. So that's $100,000 for a total of $1.1 million. And the process for participation is pretty straightforward. The applications are available online. After applying, you would receive an application approval letter. And your first step would be to do a feasibility study to really assess what's going to work in your particular situation. You would submit a completed feasibility study and then receive incentive payment. And you're saying, wait a minute, is a feasibility study actually covered under this program? And in fact, it is. It is. One of the big options that we have seen, one of the big obstacles that we've seen is that even considering combined heat and power can be a big lift. That feasibility study is the first step in this process, and you can get to a fairly expensive investment and get to the end of it and say, oh, gee, maybe it isn't really right for us. And so the folks at New Jersey's Clean Energy Program have designed a new benefit to try to help get over that obstacle. The feasibility study benefit is designed to offset the cost to evaluate whether or not this solution is right for you. And the program will offset up to 50% of the cost of a feasibility study, capped at $50,000. So now, not only do you have a sense of urgency about taking advantage of some of the opportunities that Gearoid discussed, but there now is an opportunity at the very beginning of this process to reduce the cost and get some answers as to whether or not this is something that's going to fit for your situation. Now, with that, I'd like to just kind of turn it over to you all and see if there are any questions or if we can clarify anything about the way that this program works.
Thank you, Mike. I'm not sure if others have questions that they put inside the chat already, or that they'd like to ask. I'll start by asking a couple of questions. As you mentioned, and has been mentioned a few times, one of the benefits of CHP is the resilience component. Is there a preference for applications that incorporate black start and islanding as part of their application?
And is Val with us?
I wouldn't say it's a preference, although it always makes for a good story, and it's something the Board of Public Utilities always promotes. I think there are many benefits to CHP, as we've talked about, so that is just one of many benefits, and they do offer for certain facilities, as Mike mentioned, there's bonuses for it, so they do want to promote it. But we certainly see varieties of we see just as many projects that elect to design their systems with the black start and islanding functionality as we see ones that don't, because again there are other benefits as well.
In the case of higher education, there are dorms and other facilities that need to provide food for students and need to stay afloat during if there was some sort of weather that was intermittent or some sort of disaster. Would that qualify as a critical facility where students are being housed, and would they receive a bonus as part of this?
So there is a set definition of what qualifies as critical facility in the program. So, you know, we don't decide that case by case. So if I'm looking at the program guidelines, for example, it'll go into, you know, what for this particular effort defines critical facility and what would be eligible for those bonuses. So if you give me a second, I can look it up for us.
Or you can just send it to both, I guess.
I can put it in the chat for those of you, yeah, for those that are interested. But essentially, it's any public facility, whether it's federal, state, county, or municipal, and then select nonprofits, including hospital, police, fire, wastewater, school, and then there's some other alternatives that are defined within that, you know, in this case you don't fall into those two categories. So it's not overly simple, but we do define it. So I can put that in the chat so people can read it and ask any follow-up questions.
Okay. As New Jersey is looking to decarbonize and become more renewable, is there a preference for projects incorporating a renewable component?
Yes. So, you know, there's been a lot of talk surrounding the concept of, you know, can we transition this program into the renewable landscape? You know, can we require projects to run on renewable fuel? And it's not an easy decision or an easy topic because, you know, you need an abundance of renewable fuel to run these CHP systems, and that isn't always readily available locally. So, you know, I think when you compare maybe CHP with other renewable technologies, I think that, again, it always makes for a good story and a good project that BP would welcome and highlight. Obviously, CHP running on biofuel is ideal, but again, not necessarily something that is expected on every project just because of the landscape of renewable fuel and availability of it. So it is a topic of conversation. It's an evolving discussion. But, you know, right now, again, there's even running on natural gas, the systems are still providing a benefit from efficiency standpoint, you know, grid congestion standpoint, emission standpoint. So it's not a barrier at this point.
How can attendees apply for the CHP feasibility study?
Mm-hmm. Yeah, so the feasibility study option is live on the website, the New Jersey Clean Energy or njcleanenergy.com website. I can also post that link as well after the
I'm going to put it in the chat right now.
Oh, perfect. Thank you.
Mm-hmm.
Yeah, it's slotted as a sub tab, if that makes sense, under the larger CHP program. So you may not see it unless you uncollapse it, but there is a website for it with a guide and an application form to get started. So you can, you know, take a look at that and see if you have any questions on what it is we're asking for, and then we can help you, you know, get that put together and submitted. It's a fairly simple process, although it does require, you know, a little bit of effort, because we do need to see, because the incentive isn't fixed, as Mike was showing you. It's 50% of the cost of developing the study. There's a little bit of effort required before applying into figuring out, okay, how much is this going to cost this particular customer, this particular site, in order to submit that application. But that's all spelled out in the guide and in the form.
I just posted 3 links in the chat. The first is to the page on the New Jersey Clean Energy website that discusses the feasibility study. The second link is to the application itself, so you can look over what's needed for that. And the third is I think very, very helpful. It's the program guidelines that are also online. And it goes into a fair amount of detail about the kind of things that may come to you as you're thinking about this, and we'll give you some pretty clear definitions on just about anything related to the program.
Thanks, Mike.
Is the feasibility study required for the CHP incentive?
No, so they are 2 separate offerings. So, for many years now, we've been running the core CHP program that Mike was presenting on. That was the dollar per megawatt incentive up to the $1, $2, $3 million. So that core program has been around for a while and is available, and you don't necessarily need to do a feasibility study to participate in that program. And if the feasibility study would be a nice segue into that program, right? So if you have a customer that's on the fence and they're debating whether they want to look into this further, there is some incentive for them to do that, and then perhaps that'll be enough for them to then, based on the results of the study, say, okay, yes, let's do the project, and then you can segue them into the core program, and there'll be additional incentive money there for the actual project. So they do operate independently, but the intent is to hopefully, have more projects come through feasibility study incentive program and feed into the core program to do the actual project.
Is there a deadline for program application, and how long is the approval process?
So there's no deadline per se. I mean, our program runs on a fiscal year, so we're currently smack in the middle of fiscal year 2024, which ends June 30th, 2024. So come July 1, that technically starts a new fiscal year, and so anytime we convert fiscal years one to another, there's always opportunities for changes, improvements, enhancements, things of that nature. So as of right now, there's no hard deadline, although I would, again, use that June 30th date as a kind of a bookmark saying, okay, if you got something you want to submit, I would do it by that time. Otherwise, there may be changes coming come July 1, not that I know of any at this point, but that may be beneficial or maybe less beneficial than what we have offered right now, if that makes sense.
If the customer decides not to do the CHP after the feasibility study, will they be paid the 50% for doing the feasibility study?
Yeah. So we were able to successfully, promote this offer with BPU, and they're on board to, really put this out there, right? So they are committed to paying that feasibility incentive, despite what may or may not happen after the study. So you may have some customers moving ahead, some customers not moving ahead. Some may need 6 months to think about it, so that a feasibility incentive will be paid, so long as the requirements of that study are done, to the program's requirements. But there is currently no requirement to, convert that into a project, an installation of the CHP, assuming assuming that's the case. So short answer is yes, they will still be paid.
How does one become listed as a trade ally?
Yeah. So, and Mike, I don't know if maybe you have a better answer for the trade allies. For CHP, for our program here, there's no finite list of trade allies, although we do have a broader list on the website that you could sign up for. I believe there is a category for CHP providers, developers, as well as engineering firms. But I know that's also in process of being updated. So, Mike, I don't know if you're up to speed on where the trade ally situation stands, or if it's still much as it was before.
Yeah, I could help on that. There is actually an application process that is pretty simple, pretty straightforward. And we're working to make sure that trade allies see some real value out of participating in the program with the clean energy program. So there are a whole lot of benefits to organizations that do become trade allies. I was just looking at it this morning, and it is a really good deal, and obviously it's free. And so I would be happy to again put that link in the chat, assuming I can find it quickly enough. But I'll be happy to do that. We're adding trade allies all the time.
I think I have it here.
Oh, great.
Yeah, so it's again, there's kind of a broad list right now. I know it's going through some updates, but you can certainly still sign up in the categories that best fit your services as a whether a developer, manufacturer, or energy provider, energy consultant, and then there are some benefits to that. Although, again, for the sake of the CHP program, we do not necessarily at this point require anyone to be a trade ally to participate. Although we do look at who's doing projects, and we do make sure they're qualified, but it is open to the market at the moment. Hopefully I put the right link in
there. I think you did.
Okay, good.
It's a nice way to get a little bit of extra publicity for your organization as well. It's being part of that directory, we hear has tremendous value for folks.
Mm-hmm. And I just want to mention, this wasn't part of our presentation, but if the feasibility study is even too much of a commitment for someone, taking a step further back from there, we also have, the Clean Energy Program has a no-cost energy audit program. It's called the Local Government Energy Audit Program, or LGA, but it is open to public universities as well as 501c3 nonprofits, which many private universities are. And that program is absolutely no cost and does provide a full energy audit. And if you ask, they will do a very, very high-level screening for CHP, as well as solar. Again, it's very high level, kind of very basic information, but again, it's all no cost. So that's also an option that if you have a customer, you are a customer, and you're not sure if this is the right path, that's an even less obligatory first step. And so just wanted to throw that out there. And some of you may be familiar with that program, may have participated in that program. I can put that link in in the chat as well. So lots of entry points for participation here through the Clean Energy Program for all levels of engagement.
Well, as we get close to the top of the hour here, I also just wanted to take one moment to offer up our services as you're thinking about this and navigating your way through. This is a project that we really profoundly enjoy working on, and I'm more than happy to take any calls or emails that you might have. You can get me at mholsinger@trccompanies.com, and I'll be sure to answer your question or find somebody who knows the answer. Tara, do we have anything else?
No, I didn't receive anything else. Thank you.
And thanks to
Okay.
Gearoid, it is great to have his expertise available as well.
Yes, absolutely. Hopefully it was productive, and like Mike said, we are readily available for any questions or follow-up.
Sure, and just to kind of iterate from my perspective as DOE, we're sort of in transition with our program, but we're certainly available, and traditionally we will support TRC, so we'll help to support them and bring our expertise to bear. If somebody has any questions or issues, reach out to Mike or Valentina, and we're available to support them to kind of help move things forward as well if you need.
Thanks, everybody.
Thank you.